Okay, everybody, this is going to be like a review of Algebra 2 when you guys studied transformations. We're not going to talk about parent functions just yet. We're going to talk about any generic f of x or g of x or h of x function that you've been given that you want to move around. So the idea is that you have a function, right? F of x is going to be the name of this function. And these different types of transformations right over here can be applied at any time, right? And you can have one transformation at a time or a whole slew of them. So what you're looking for here is if you're going to see an A or a B, a negative in the front, are you going to see a number on the outside or a number on the inside? So the way this would look, okay, is I'm going to keep this f of x, and if you have a bunch applied at one time, it might look something like this. You might have the A on the front. You might have, this would be the f of x. And you could have like a B term. You could have, I'm going to call, this would be the h and the k, right? H and k. All right, so if you were to see this like a bunch of transformations all on one, it would look something like that. And so you'd be identifying these numbers, where they are, and what they would be doing to your f of x. And so the list, to refresh your memory, is all over here on the right. You've got your vertical stretch shrink here. You've got a horizontal stretch shrink here. You've got left, right, and you've got up, down. And so just to make an example so you can sort of see where we're going with this, is if I were to do something like 3f of, maybe it's like negative x plus 2, something like this, okay? I'll even put that in an extra set of parentheses. Okay, so if this was given to you, the first goal or the first thing that I recommend is to go through and find the f of x and ignore it. I know that sounds ridiculous, but I always extra highlight it, or in my mind I try not to stare at it, because what you're looking for is all of the things that are around it, okay, these things that I'm circling. So the stuff in green, in other words, is going to be what I really need to focus on. Now, the 3 that's in the front is just like above where there's an A in the front, right? So I'm going to look over here, if I don't remember from Algebra 2, and that is going to control my vertical stretch or shrink. Now, 3 is definitely bigger than 1, right? So I know this is going to be a vertical stretch by a factor of 3. What does that mean? It means I am stretching it vertically 3 times greater than it already was. Another way of thinking about it, guys, is that that is going to multiply your y values by 3. I'm not going to write that, but you might want to. That's going to be multiplying the y values of your graph by 3. Okay, now there is a negative that's been sort of nestled in between the f and the x. So if we look over here, it's going to match that one. So in my description of what's happening, I'm going to say that there's going to be a reflection over the, what axis would that be? Well, that would be the y-axis. Some people also call this a horizontal reflection because you're reflecting it side to side over the y-axis, so some people would call it a horizontal reflection. In fact, I'm going to add that word horizontal to the front. And then we have a plus 2. It's on the inside of the parentheses, so that means it's like the H. And when you're inside of parentheses, it does sort of the opposite of what you think. So I know it's a plus 2, and you're probably thinking, oh, positive 2 goes to the right. No, it doesn't. Positive 2 actually would go to the left. So whatever number you see there, you are going to do the opposite, okay? All right, so let's do an example with a graph now. Okay, so what we're going to do is go from a graph now, and we're going to call this the original f of x, or whatever they decide to name it, and then we're going to be asked to perform different transformations and just see what happens to the graph. So I think I'm going to just try to lay quite a few things on here. Let's do maybe, let's do a negative 1/2 f of 2x minus 4. Whew, okay. So that's a lot, and hopefully I can talk through this without boring you pretty quickly. Okay, so I like to perform my transformations going from the left to the right. In other words, I'm going to handle what's in the front first, then I'm going to do the 2, and then I'm going to do the negative 4. Okay, so a negative in the front and a 1/2 in the front would be like having a negative a. So I'm going to highlight that over here. So I know this is going to reflect over the x-axis, but also, I should have highlighted this one, the a is a fraction, so it's going to shrink by a factor of 1/2. And what that means, guys, is just it's going to be half as tall as it was before. So I'm going to switch to red so that you can see this happen in red. I'll kind of color code as we go. All right, so I'm going to reflect this, and at the same time, it's half as tall. So an easy way to do this, like the easiest, is to multiply all the y values by whatever is in the front, and this works every single time. So like this y value right now is a 0. If I multiply it by negative 1/2, it stays a 0. This y value right now, see our scale is by 4s, so this y value is actually negative 8. So if I do negative 8 times negative 1/2, it's actually a positive 4, so it's going to move there. This y value also moves to the same spot because it was the same y value. This place where it crosses at 0, I always, even if it's not, it doesn't have a point on it, I like to do my zeros, because if it's 0 and I multiply it, it still stays there. It just gives me a better guide for my graph. Let's see, this y value is a 4, so I'm going to do 4 times negative 1/2. So what would that be? 4 times negative 1/2 would be negative 2, so it's going to be right here. Remember, this is scaled by 4s, guys, so I'm having to be really careful where I put my y. And then this one is a y value of 8, so 8 times negative 1/2 is actually negative 1/4. And now I'm going to play connect the dots with this. And when I play connect the dots with this, I am getting a graph that looks something like this, okay? So it's this graph that's been sort of reflected. And I know that looks like a straight line. It probably is, but it just kind of changed the shape of the graph because of, you know what, did I put that at the wrong spot? Silly me. I was wondering why that looks so derpy. This was in a bad spot. Sorry. It was supposed to be at a negative 4. I think I put it in a negative 8. It was supposed to be there. Okay, good. Because see, I wanted to see the same shape. You know how this kind of goes up and then tilts a little bit? That should do the same thing, but it's going down and then tilts a little bit. Okay, so now we have the red graph. So I wish I could erase the blue, but I can't. But if I could, I would ignore the blue one. I would have this red one, and then I would focus on the next step, which the next step is the 2 right here. And this is one of the hardest transformations for people to do. A 2 on the inside is a B. And it looks like we're doing this one because the b value is bigger than 1 because it's a 2. So it says that we're going to shrink the curve horizontally by a factor of b, which means that we're going to shrink. It's almost like you're on the sides and you're pushing in from both the left and the right, and you have to shrink it twice as much as it was before. So a way to do that easily is to take your x values and do the opposite of what you see. So instead of multiplying by x values by 2, I'm going to take my x values and cut them in half. So hopefully that makes sense. Instead of multiplying by 2, you're dividing them by 2 or cutting them in half. So in other words, this x value here, right, is normally at negative 16. If I cut that in half, it's going to shrink all the way in to right here. Okay? This x value, I'm going point by point. So this x value was a negative 8, so half of negative 8 is negative 4. This x value was 0, it's going to stay 0. This x value was at 4, and I'm going to cut that in half, so it's now here. This red point is at 8, 8 cut in half is 4, 16 cut in half is 8. So once I retrace this picture, hopefully y'all can see what I was talking about in terms of the red graph has been compressed twice as much, and it now resides in this tiny little space here. And then the last thing that we are going to do is why did I scratch you out? The -4 at the back. So the -4 is outside the parentheses, which means that it is like a k value, and it's going to move everybody down by 4. So I don't think I have another good color. I'm just going to go to boo. I'll go to blue, and then I'll highlight it at the end. So I'm going to take the green and shift everything down by 4. So there's down by 4 there. There we go. Down by 4, down by 4. This is the easy part. And 4, you know, once again, the scale was wonky, so 4 is just one block on our grid. Okay, so I'm trying to build it. I'm going to go ahead and highlight the final. All right, so the final highlighted in blue. And so all of those transformations applied to the original blue graph ended up being this highlighted blue graph. Hopefully that makes sense and helped you out a little bit. Like I said, I tried to make this hard. They're usually not that difficult, and they usually don't have that much going on at one time. But this is pre-cal now, so you know stuff can happen. So hopefully it helps out, guys.